Hello children, today our new lesson is lesson number 22, sets lesson. Okay, under this lesson we will recall what you learned in previous grades. Okay, firstly we will see what is a set. What is a set? You have learned that set is a collection of items that can be clearly identified. What is a set? A collection of items that can be clearly identified. For an example, we can take vegetables, fruits, birds, likewise. And in mathematics side, we can consider even numbers, odd numbers, prime numbers, composite numbers, triangular numbers, square numbers, likewise. Okay, and moreover, when we consider vowels in the English alphabet, colors in the rainbow, likewise. Okay, all these items can be clearly identified as a set, so they are the examples for the set. But when we consider famous people, famous singers, clever students, beautiful flowers, likewise, are those clearly identified sets? No, they are not called as sets. Okay, okay children, what are the elements? What are the elements? Elements are the items in a set. Items in a set are called the elements. For an example, I told you even numbers. Even numbers is a set. It is a clearly identified set. So in even numbers, we know that 2, 4, 6, 8, those numbers are there. So those items are the elements. Okay. Then colors of the rainbow, when we consider red is there, orange is there, blue is there. So those are the elements. Okay, those are the elements of that particular set. Okay, then as the third one, we will learn the methods of writing a set. Last year also you learned that there are 3 main methods to write a set. The first method is what? As a description. We need to write a description of the set as a common property of the elements, no? So as a description only we write it. So it is one method. The second method is writing the elements. Writing these elements by listing. Okay, by putting commas within curly brackets we can write it. If there is a name for the set, we should write that also. Okay, and the third method is Venn diagram. Inside a circle we included all the elements. Can you remember? Okay, anyhow in the second and third methods, that means by listing elements, and in Venn diagram method we don't repeat the same element. If there are same elements repeating, we are not writing them, those. Okay, then I have given you one example here. X is a set. What is the name of this set? X. So in this set, what is this set? Prime numbers from 1 to 10. Okay, firstly we will identify what are prime numbers from 1 to 10. Okay, so as a description, when you write, firstly write the name of the set, and within curly brackets you need to write the description. Okay, so get the use of the question. We can see what is this set X, prime numbers from 1 to 10. So with the help of the question, you can write the answer here. Prime numbers from 1 to 10. Okay, the second method is by listing elements method. By listing the elements. Okay, what are the prime numbers from 1 to 10? 2 is there, 3, 5 and 7. These are the prime numbers from 1 to 10. And by a Venn diagram, when we represent the set X, write the name of it by putting an arrowhead, and inside the circle we can include this without putting commas. 2, 3, 5, 7, wherever that you want, don't put commas here. Okay, so after this you learnt about a small symbol like this. Okay, this shows that is an element, not an element. For an example, when we consider set X, we can say 2 is an element of set X. 5 is an element of set X. So how do we write it as a symbol? 2 is an element of set X. Then 7 is an element of set X. Okay, but we know that 10 is not an element of this set X. 10 is not. So if you are writing that, you can write like this: 10 is not an element of set X. If it is not so, cut the symbol like this. And 6 is not an element, so we can write 6 is not an element of set X. Okay, this is how we use this symbol. Okay, and the other one is number of elements in any set. Okay, consider set X that we have taken for the example. How many elements are here? 1, 2, 3, 4. There are 4 elements now. So how do we write it as a symbolize? See, this shows the number of elements in set X. This simple N represents the number of elements. Put it outside the bracket, and inside the normal brackets parenthesis you can put the name of the set. Okay, there are 4 names, so you can write 4. If we consider the colors of the rainbow, just think I'm giving a name for that set as A. A represents the colors of the rainbow. Okay, how many colors are there? 7 colors now. So the number of elements in that set is what? 7. So this is what mainly you learned in your previous grades about the sets. Okay, now we will learn about null set. What is a null set? Null means nothing. That means a set with no elements. There are some sets which have no elements, so they are called null sets. So how do we represent null sets? See, these are the 2 symbols that we can use for the null set. Empty curly brackets can be used because there are no any elements now. So you can write like this, or else this is the symbol that we use for the null set. Okay, then what can you tell about the number of elements in any null set? Are there any elements you can see here? No, empty curly brackets, no. That means number of elements must be 0, no elements. Okay, for an example, I have given you this set A, multiples of 5 between 5 and 10. Okay, between, whenever you see between and, we don't include the boundaries, you can remember. You have learned this when you were in grade 6. Okay, so if we are not including the boundaries, what are we writing as the elements here? What are the multiples remaining between 5 and 10? No elements. So we know that number of elements in set A is 0. This is a null set. So simply you can write A is a null set like this. Number of elements 0. Now go to the next example, set X, integers between -1 and +1. Okay, when you consider the number line, you know that 0 is there, -1 is in this side, +1 is in right side. So are there any integers between -1 and +1? We cannot include -1 or +1 because of the words between and. Okay, so what are the elements here? 0 is there. Most of the time when our children see this, they think that this is also a null set, but this is not a null set because we can see one element in this set. Okay, so the number of elements in set X is what? 1. So is it a null set? No, it's not a null set. This is not a null set. This is the difference. Most of the time we get confused with this. Okay, right. I hope that you got an idea about the null set also. Now children, we will learn about finite sets and infinite sets. Okay, firstly, finite sets. What are these finite sets? These sets have a finite number of elements. That means there is an exact number of elements in these type of sets. So they are called finite number of sets. For an example, even numbers from 1 to 10. Exactly we know how many are there: 2, 4, 6, 8, 10. Okay, from 1 to 10 we know that there is an exact number of elements here. So it's a finite set. Okay, another example, set B, positive integers less than 25. Okay, that means from 1 to 24 we can write all the answers there. We know that exactly there is a certain number of elements here. Okay, so it's a finite set. Then vowels of the English alphabet, or else letters in the English alphabet. In both the sets, we know that there is an exact number of elements. We can write and show it. Okay, and when we go to the infinite sets, infinite set means, okay, a set which has an infinite number of elements is called what? Infinite sets. No end. There is no any end for the elements there. For an example, even numbers. When we write even numbers, there is no any end. Up to infinity we can write. So 2, 4, 6, 8, 10, 12, 16, 14, 16, 20, likewise we can write so many. Okay, so cannot write all. So what do? We write few elements, and after putting a comma at the end of the set, and at the end of the list, we can place 3 dots to show that to continue other numbers also. Okay, another example, positive integers. What are the positive integers? 1, 2, 3, 4, 5, 6, 50, 100, likewise there are so many positive integers, no end, not like these examples, am I right? So cannot write all. So you can write y equals 1, 2, 3, 4, enough. No, write 4, 5 elements. Thereafter place 3 dots at the end of the list. Okay, then close the curly brackets. Next one, polygons. We know that triangle, quadrilateral, pentagon, hexagon, heptagon, likewise there can be polygons with so many sides. Okay, you may have learnt only few, but there are so many polygons with so many sides. So no end, that is also an infinite set. Okay, so these are the examples for infinite sets, because they don't have an exact number of elements there. Okay, they have an infinite number of elements, that's why we include them to this side. And these are the finite sets, they have an exact number of elements. Now children, we will learn about equal sets and equivalent sets. Okay, see this side, equal sets. Okay, by the name also you can remember this. I have taken 2 examples to explain this. First set is set A, letters of the word pot, and the second set B, letters of the word top. 2 different sets. Okay, but when we write the elements of these two, see P O T, here T O P, same elements, no? Same elements can be seen. So when there are same elements, same number of elements, then those sets are equal sets. If there are same elements, if there are same number of elements, so they are called equal sets. Okay, so this is how we represent them. A set equals to B completely by the elements and by the number of elements in both the ways. Okay, next, equivalent sets. In equivalent sets, children, here I have taken 2 examples. Letters of the word pen. Okay, we will write letters of the word pen, P, E, N. Okay, the next set is multiples of 5 from 5 to 15. What are the multiples of 5 from 5 to 15? 5, 10 and 15. Okay, are they same? Can you see same elements here? No, they are different, but only one equality we can see here. What is that? The number of elements. The number of elements in both the sets are equal here. Okay, though the elements are not same, if only the number of elements are same, we can call them as equivalent sets. So remember the difference between these two. Here all the elements are same, the number of elements are same, that means, okay, so they are equal sets. But here the elements are different. See, I have written here, the elements are different, but the number of elements are same. See, the number of elements in set X equals to the number of elements in set Y. So they are equivalent sets. This is how we represent them. equivalent set. This is the symbol. Okay, right. I hope that you understood this one. Okay, now we will go to this example. We will see what are the equivalent sets and equal sets here. Before that, see, you are given 4 sets. Firstly, you write by listing elements. All these 4 sets should be written by listing elements. Then only we can decide whether they are equal sets or equivalent sets. Okay, see the first one, set P. Digits of the number 2505. So 2, 5, 0, 5. Again, no need to write, okay, because it is repeated. Q, set Q. Letters of the word time, T, I, M, E. No letter is repeated. Set R, square numbers from 1 to 10. From 1 to 10, we know that 1 is the first square number, second square number is 4, third square number is 9, only this much. And set S, digits of the number 91,491. So 9 is there, 1, 4, 9 is written, 1 is also written. Okay, now you see what are equal sets. Can you see the same elements here? See, in these two we can see the same elements are there. That means set R is equal to set S. These two are equal sets. Okay, then other than this, are there any equal sets? No. Now we will go to equivalent sets. That means elements can be different, but the number of elements must be same here. See, PR, PS, those two are equivalent sets. We cannot write RS because they are equal, but when we consider equivalent, P is equivalent to set R and set P is equivalent to set S, because there we can see only the number of elements are same, so they are separately equivalent sets. So if you are given a question to find equal sets and equivalent sets, first of all you write the elements of those given sets. Thereafter you can decide by putting the relevant symbol there, you can represent them. Okay, now children, we will learn about subsets. Okay, what are these subsets? When you consider a set, okay, in that set all the elements can be seen in another big set. Okay, so at that time that small set is a subset of that main set, main big set. Okay, for an example, if I explain with the help of these 3 examples, I have given you 3 sets. In the first set, 1 to 5, all the digits are there, and set Y we can see 2, 4, 5. In set Z, 1, 3, 7 can be seen. Okay, so look at set Y, 2, 4, 5. All these 3 elements can be seen in set X. No, see, 2, 4, 5. So if all the elements in one set can be seen in another set, so this small set is a subset of that main set. So how do we write it with the symbol? Y is a subset of set X. Okay, as a sentence also I have written it here, Y is a subset of X. It happens no, Y is a subset of X, so it can be written by symbolizing also Y is a sub. This is the symbol we use for the subsets. Okay, then go to set Z, 1, 3, 7. Okay, 1 is here, 3 is also there, but 7 is not there in set X. Though there are 2 elements in this set, we know that the last element is not available in set X, the main set that we considered. So we cannot see all the elements in this set, right? So that means Z is not a subset. Though there are 2 elements, all the elements can't be seen inside that set. No, so we can say that Z is not a subset of set X. So how do we write it? Z is not a subset of set X. Cut the symbol if it is not a subset. I hope that you understood. Most of the time you are given the questions in descriptive format. That means within brackets you may be given a description. But with that description we cannot go ahead now. So you better write all the sets by listing elements like this. Thereafter you observe whether all the elements can be seen in another set and another main set. If it is so only, we can write them as subsets. Okay, even a single element can't be seen in the main set, they are not subsets. Okay, right, now go to the other side. As the first question, you are given all the subsets of, write all the subsets of the given set. We can see A and B elements. Okay, here you must remember two main things. When you write subsets in any given set, mainly you should write the null set. Null set is a subset of any set, and also the set by itself. The set itself is also a subset of the given set. Okay, so remember to include those two. Right, now here, as I told you earlier, null set, this symbol or else the symbol given by me earlier can be used for the null set. Null set is a subset, and the set itself we can write, the whole set can be seen. Thereafter, according to the number of elements there, 1 by 1, 2 by 2, 3 by 3, you can take the elements there. So here we can take 1 by 1, no, A separately, B separately. A can be seen in that set completely, B can be seen in that set completely. Alright, okay. So for an example, if I am just writing here 1, the set Z is just only 1. Only 1 can be seen there. Yes, of course it is a subset. It is a subset of set X. Okay, at this time only. Right. Next one, all the subset of the given set. First of all, we will write the null set and also the set itself. Now, as I told you earlier, 1 by 1 we will write A separately, B separately, C separately. Now 2 by 2, A, B together. This is a subset. All the elements can be seen. Next, AC. Next, BC. Only this much, right? Yes, these are all the subsets. There, how many subsets can be seen here? There are 4 subsets if there are 2 elements here. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements, 8 subsets for a set which have only 3 elements. Then here I have given you the null set, and the set itself are subset of any given set. So if you are given a question to write all the subsets, firstly start writing the null set and the null set itself, then go ahead. Now our next subtopic is universal set. Okay, I have given you the definition of the universal set. Set which contains all the elements, a set which contains all the elements under consideration. Will you be able to understand this? Okay, I will explain it with the help of some examples. See, this is my first example. Here I have taken few sets here. What are those sets? Male students, grade 9 students, O-level students, students who are in the school cricket team, and grade 8 students, grade 6A class students. Likewise, we can take students anyhow. All these students belong to one school, no? Okay, so as the universal set for all these sets, we can take what? The students in the school. Okay, here another example: even numbers, odd numbers, triangular numbers, square numbers, negative numbers, all these are numbers, no? So for all these we can write a universal set, a common set. That means all the elements which belong to these belong to that main set also. That main set is what? Integers. In integers all these numbers can be seen. Okay, right, we cannot write letters in the English alphabet now here, because these are just the numbers. Okay, look at this one, vowels of the English alphabet. Some letters are there, we can take it as the letters of the word pot, the letters of the word tin. So these are some examples. Anyhow, all these are letters in the English alphabet now, not in Sinhala alphabet, not in Sinhala audio now. So we can write here letters in the English alphabet. That is the main set that has all these elements. Okay, so we can write any universal set under consideration there. Okay children, now we will learn about the Venn diagrams. You have learnt about the Venn diagrams already, but here we are going to learn more about the Venn diagrams. Okay, here I have given you a small definition also. In Venn diagrams we can represent the sets, no? The sets by closed figures. Here every time we should use closed figures, rectangles, circles, ovals, like these only we can use. Remember, closed figures should be used to represent sets as a Venn diagram. Okay, now our first situation is when there is only one subset. Now you know what are subsets. Okay, when there is only one subset, how do we represent it in a Venn diagram? Okay, up to here you have learned just only this one, no? Whenever you recall the Venn diagram without this rectangular part, no, you learned. Okay, now we learned about the universal set also. Okay, under the consideration we think that universal set is the biggest set that we consider there. Okay, so here usually the universal set should be represented by a rectangle. Okay, that is the way the rectangular part completely represents the universal set, and inside that rectangle we can include circles or ovals to represent the subsets. The subsets of what? The subsets of the universal set. Okay, see, this is the universal set. In that universal set there can be subsets, there can be one or more, but here we learn only about one subset. Okay, so whenever you include a subset to the universal set, with the help of an arrow you should label it, you should name the relevant subset. Okay, right, and also this symbol should be put above the rectangular part, rectangle, that is because that is the symbol to represent the universal set. Okay, here I have taken one example here. In the universal set there are numbers from 1 to 6, and I have taken another set called A. It has 2, 4, 6 as the elements. But see these two, whether all the elements can be seen or not. Okay, see, 2 is here, 4 is also here, 6 is also here. If it is so, how do we represent both using a Venn diagram? Firstly, you should draw a rectangle to represent the universal set, and you know there is a subset. This set A is a subset of the universal set because all the elements can be seen in the universal set. So I am drawing a circle and I am naming it as A because the name of this set is A. Put the relevant name there, and inside this circle I am putting all these elements 2, 4, 6, 2, 4, 6. And you know that there are some more elements which belong to the universal set but not to set A. Okay, so outside the set A, outside the circle A, we can include the rest of the elements. What are those? 1, 3, 5. Because they belong to the universal set but they do not belong to set A. See, this is how we represent such an example. Okay children, earlier we learned how to represent one subset in a Venn diagram, that means including the universal set. Okay, now we will learn how to include two subsets when there are two subsets in the universal set. Okay, right, there are 4 situations that you need to remember. These two subsets can be there in different ways, okay, according to the elements that they have. Okay, this is the first situation. According to the first situation, if I am taking here the two subsets as A and B, okay, the two subsets that I am considering are A and B, okay. In these two subsets, if there are no common elements, those two subsets should be represented here separately. We know that inside the universal set, inside this rectangle, now we need to include the subsets. Anyhow, they don't have common elements. Firstly, put the symbol to represent universal set. Okay, I am representing set A like this. Write the name of the set. Okay, because there are no common elements, I need to include the second subset separately. This is second subset B. No common elements, that's why we need to draw them separately. Okay, now children, the second situation here, there are common elements for the two subsets that we consider here. For A and B, there are common elements. Okay, if it is so, this is how we represent them. This is set A and this is set B. Should name them, should name the sets that you include. This is the common region. This region, inside this region we can include those common elements for both the sets. Okay, and in this side, in left side, you can include the elements which belong only to B, and in this side you can include the elements which belong only to set A. Okay, but here common elements for both can be included here. Okay, this is the Venn diagram when we draw for the common elements one. Next, third situation, one set is a subset of the other one. For an example, you just think B is a subset of A, or else to the other side also you can take A can be a subset of B, but here I have taken set B is a subset of set A. That means completely the elements in set B belong to the set A. So at that time, this is set A and the subset is B, no? So inside that only I need to include set B. Actually, as we learned earlier, A and B both are subsets of universal set, no? That's why inside the rectangle we include them. In the same way, we can think that B is a subset of A. If it is so, inside set A only we can include the set B there and name that universal set here like this above the rectangle. Okay, I hope that you understood this. If there are all the elements, if all the elements in set B belong to set A, that is a subset of A. This is how we represent it. Next, fourth situation, both the sets are equal. When two sets are equal, we know that the number of elements are same and also all the elements should be same. Okay, at that time the same circle can be labeled as A and B because both are same. Okay, it can't be drawn like this. All the elements are same in A and B, so this whole circle represents A, B both. So these are the four situations that you need to learn when there are two subsets which belong to the universal set. Okay children, now we will learn about the intersection of a set and the union of a set. Okay, so these two are two main parts of the lesson sets. Okay, intersection can be represented by this symbol. Okay, and the union of a set can be represented by this. There is a small difference. Just think this is a cup and the cup is turned upside down. Okay, so remember only one thing. Okay, intersection can be represented like this. Cup is to the other side, and the other thing is to show this intersection sometimes in, that means in a sentence, if we have included word and, it shows us the intersection. That's why within brackets I have written and. Especially as a sentence, when we write the intersection, we use and when we write the union in a sentence, we should use what? Or. Remember those two, the two symbols and the two words mainly that we use here. And the main idea that you need to take here is intersection. When we consider intersection, there should be two or more sets here. Okay, if there are two sets, we can think that the intersection is the common region or the common elements. Okay, so here I have taken one example. In set A, 2, 3, 5, 7, 11 are there. In set B, 3, 5, 6, 8 are there. So can you see any common sets here? 3 can be seen in both. 5 can be seen in both the sets, and only that much. Yes, so 3 and 5 are common elements for both the elements. So when we consider the intersection of set, it is also a set like this. These two are sets, no? Likewise, when we write the intersection in this way, it is also a new set. Okay, so A intersection B means the common element, a set with the common elements of set A and B. So what are those? 3 and 5, no? So within curly brackets we can write that new set. What are the elements of this new set? 3 and 5. Then what is this? The union. Okay, when you write the union, you should write everything in both the sets here. That means all the elements in set A or B. What are the elements that we can see in A, B? All within curly brackets we will write 2 is there, 3, 5, 6, 7, 8, 11. In an order, in the ascending order I wrote this, but it is not compulsory. Firstly, you can write all the elements in set A. After that, you can write the elements in set B without repeating the same elements. Hope that you understood this. Okay, so this is the intersection. Again, I will explain. A intersection B means the common elements, a set with the common elements of set A and B. A union B means all the elements in set A or B. Okay, if we are representing all the elements in this universal set, here I have written the symbol here, and we know that there are common elements, no? So how do we draw them? In this way. Hope that you can remember the second situation. When there are few common elements, this is the way we need to represent the set. So in this side I will represent set A, in this side I will put B. Okay, what are the common elements? 3 and 5, no? So we need to include them to the middle region because it shows the intersection of both the sets, the common region, the common elements should be included there. Okay, other than these two, what are the other remaining elements? 2, 7, 11. They belong to set A but not to the set B. So here we will write 2, 7, 11. And when we go to set B, 3 and 5 are already included. It belongs to set B also. But what are the other remaining elements that belong to set B? 6 and 8. We can include them like this. In this example, according to this example, they haven't provided us any universal set. Otherwise, we need to put the remaining elements inside the rectangle but outside the two circles. But here we don't need to do so because we are not given any universal set. Okay, right. So when we shade the regions here, just a rough sketch I am drawing here. Set A, B. If we are shading the region under this, the intersection of A and B, we know that it is the common region. You should shade the common region and show it. Union means all. Here, union means all. All in where? In the sets in either sides. So A, B, both should be shaded like this. Okay, right. Next, as the second example, I have given not the elements but just two sentences. Set X represents the students who play cricket. Set Y represents students who play football. There is no any mention about these students, whether the ones who are playing cricket are playing football also. Such details are not provided. They have just given us students play cricket, students who play football. Okay, now we need to write as a sentence these two. What? A intersection B. That means, how do we write it? What is the word that we use? And students who play cricket and football. No need to write everything twice. You can simply write students who play cricket and football because of this symbol intersection. Okay, that means there can be students who play both the games. Okay, next here we need to use what? And word. Okay, and students who play cricket and football. Next, union. Union means all. That means students who play cricket or football. We want all the students who play cricket or football. So simply you can write it by putting these two words. Okay, if you are not given any elements. Okay, now we will learn how to shade the relevant regions according to different sets. Okay, firstly we will consider the intersection. Intersection can come in different ways, in different situations, as I told you earlier. So the first one is this. Here how can we represent the intersection? Where is the intersection part? Here in the middle. The common region, intersection means the common region for both A and B is here. So this is the intersection part of these two sets. Okay, next, when B is a subset of A, what is the common region for both? That means this one should be represented. Okay, A intersection B. For A and B, where is the common part for A and B both? This set B completely. All the elements in set B belongs to set A also. So that part is the common region for both B and A. No? So this is the intersection of A and B two sets. Next, when both the sets are equal, the common region is what? The whole set. This is the common region. All the elements in set B are in set A also. Okay, next one. This is a disjoint set. Are there any common elements here? Actually they are separated, no? That means there are no any common elements. That means the intersection set, the intersection of A and B set is a null set. No elements are there, so nothing to shade there. Okay, so remember these four situations under intersection, common regions. I have shaded the common regions according to the sets given here. Here in disjoint set, no any common region. Now children, we will go to the union. Okay, this is the union of set A and B. Union means everything, all the elements in set A, B, both. Okay, now we will go to our first example. One can come like this. Okay, everything in AB, that means both the sets should be shaded. All the elements in set A or B. Next, all the elements in set A and B. Not only B now, A also should be shaded. All in AB. Next, all in AB, that means AB both are same, no? So the same previous one I kept. Okay, next, all in AB. This is set A, this is set B, everything in set A and B. So here I have shaded the union of set A and B in different situations. Okay. Now children, we will learn about the complement of a set. Okay, now we will learn about the union and the intersection and how to shade the regions regarding all these, and now we will learn about the complement of a set. Complement means not that set. Okay, this small dash is used to represent the complement. Okay, here I have given you the complement of set A can be represented by A dash. Whenever you see A dash, B dash, Q dash, that means complement of that particular set. Okay, that means not set A. Whenever you see P dash, not set P. When you see Q dash, not set Q, but the rest of the things can be included. Okay, for an example, I have given you one subset which is included to the universal set. Okay, so we need to write set A dash. Okay, by listing the elements, A dash should be written. So within curly brackets I can write the elements. Okay, what are the elements in set A? 1, 3, 5, no. So not A dash means complement of A, not A we want. Close that set A. Not A, no, but outside that region, what are there? 4 and 2. These two elements do not belong to set A. Okay, this is the complement of set A. Next, I have given you one example in words. Universal set represents students in a school, for an example. Okay, and from that, out of that, I have taken another example, another set B. What is that? Students who play cricket. Students who play cricket. If it is so, what should be? B dash, not B. Not B. Complement of B means not B. That means students who do not play cricket. Okay, negative meaning of this set. Just think, by set B I have given you students who are in grade 9 classes. Okay, if it is so, B dash should be what? Students who are not in grade 9 classes. Not word should be included here. Then if I am including female students, then we can write not female students. That means male students also can be written there. Okay, so not should be included. Students who do not play cricket. Now we will go to this example. In this example, I have given you two subsets with an intersection. Can you remember the common region intersection? Right. Now here we need to write the elements of X dash set and set Y dash. That means complement of set X. Now you know this is set X. Complement of set X means not X. Okay, cover set X, then all the other elements should belong to this one. If this is set X, when we cover it outside that circle, we can see X dash, elements of the complement of X. So what are those? 4 is there, 3 is there, and 2, 9, 7. Don't write 1, 0, 5, 10 because they belong to set X, but all the outside elements should be written for X dash. Now Y dash means complement of Y. Okay, not Y. Close Y then. So the rest of the things should be written here. What are those? 3, 4, 5, 10. If you want, can write in ascending order also. Okay, right. Then in our last example, as the universal set, I have given you 1 to 4 numbers, and set P we can see 2 and 4 as the elements. If it is so, what should be? P dash. Okay, number 2 and 4 should be the elements in set P, no? So P dash means not P. That means 0, 1, 3 do not belong to set P. So that is P dash, intersection of P. Okay, now in Venn diagrams we have that shading part also. No? So how do we shade intersection of set P? I have named this set as P. If this is set P, outside that circle but inside the rectangle, P dash can be seen. That means the complement. Complement means not P. Here I have shaded P dash. Understood? Okay, now this is our next example. I have given you a Venn diagram Okay, so with the help of this Venn diagram, we will write the elements of the given sets. Okay, right. We can see two subsets of the universal set X and Y, and there is a common region also. This common region is the intersection. I hope that you can remember intersection. Okay, firstly we will write the elements in set X. Just in set X circle, what can you see as the elements? We can see what? H, E, B, D. Next is set Y, this full circle. What are the letters we can see? A, F, I, E, H. As you wish, you can write, there is no any order. Next, the universal set means inside the whole rectangle, what are the elements you can see? Right, if you want from outside, you can start from one region, you can start. From outside the circles, I am starting G, C, J, I am writing first. Thereafter this side A, F, I, then H, E, B, D. Start from one region. So easily without missing any element, you can write all the elements here. Next, the intersection cup is to this side. Okay, intersection means the common region for X and Y, this one. So what are the elements in that new set? E and H. You can write HE also, right? Next, the union. Union means all in X, Y. That means in X circle and in Y circle, everything should be written, but don't repeat the same elements. Okay, I'm starting from Y. A, F, I, in this region H, E, next B, D. Next, we will go to the complement. Complement of X, not set X. Close set X, this is set X, not X we want. When we cover set X, we can see outside that circle, everything should be included. Okay, I am writing all inside the rectangle but except the circles. Then this region also A, F, I. Don't write H, E, B, D. Except these four, you can write all the others. Y dash means not Y, complement of Y. Cover set Y. All the other letters can be written. Again G, C, J. Next B and D. In next example, I have given you some elements in sets including the universal set. Now we are going to represent everything in a Venn diagram. Okay, before drawing the Venn diagram, firstly you go through the elements here, because we don't know whether it's a type of this or it can be a subset. It can be like this, or it can be a subset, it can be the same set sometimes. Okay, we don't know that one. So go through all the elements here, especially A and B, the subsets of the universal set. Okay, now you can see element 1 is common, 2 is also common, 5 is also there, 6 is also there. All in set B can be seen in set A. That means B is a subset of set A. In earlier it is not so, only H and E are common to both the sets X and Y, but here of course they are common, but all are common here. Okay, all, each and every element can be seen in set A also. So B is a subset. If it is a subset, we need to go to this option, not to this or not to this. Okay, right. After deciding that only, you can draw the two sets. Okay, this is universal set. The big set, I am naming it as A, and the small set inside the previous set I am putting B. So inside B we can put 1, 2, 5, 6 all. Now already they belong to B and A both, no? Okay, A means the whole set. Now 1, 2, 6, 5 have been included to set A already. Now what are the other elements that we need to include to set A? 4 and 7. They do not belong to set B, that's why outside circle B, but inside circle A we included 4 and 7. Understood? Outside set B, but inside set A we need to include the rest of the elements. Now you see whether there are any other remaining elements that we can put outside these both the circles. Okay, now we have already included 1, 2, 4, 5, 6, 7. All are included except 0 and 3. Where should we put them? Outside both the circles, but inside the rectangle, because they belong to the universal set, but they do not belong to A or B. So 0 and 3 can be written wherever that you want, inside the rectangle but outside the circles. Okay, right. If I am asking an additional question like this, need to write B dash. B dash means complement of B. Close set B. After closing it, outside that set B you can see some more elements. No? Those are the elements of complement of B. That means not B. 0, 4, 7, 3. Okay. If I am telling you complement of A, close the full set A, because these also belong to set A. No? So close, cover set A. A dash means 0 and 3. Likewise, you can get the answers. And the other one, A intersection B. Intersection means common region for A and B both. This region is common to B and A both. Okay, if you are given to write the elements, you need to write 1, 2, 6, 5. Union. Union means all in A or B. That means 4, 7, 1, 2, 6, 5, all in both the circles. Okay children, hope that you understood the lesson, and now you can do the exercises in your textbook, and in our online session we can discuss the answers and you can raise your problems regarding the lesson.